What's up, guys? We're going to keep up with Chapter 5 here, moving into Section 2 on direct variation. Here are a few vocab words that you'll want to make sure that you pause and copy down. Direct variation is a relationship that can be represented by a function in the form of y equals kx. Right here, this is y equals kx. And we'll talk a little bit more about this in a moment on this slide, but I want to mind you going ahead and writing. This is slope-intercept form when the slope is 0. Okay? Or not the slope, when the y-intercept is 0. Excuse me, I misspoke there. So when the y-intercept is 0, we get something called direct variation. The constant of variation for a direct variation k is the coefficient of x. In other words, the number in front of x. By dividing each side of y equals kx by x, you can see that the ratio of the variables is constant. Y divided by x equals k. This is very, very important. If you remember this right here, then you could find that constant of variation very, very quickly for something that has direct variation. So make sure that you have this all copied down. Here's our daily funny. You ever heard of the movie Constipation? Nope. That's because it hasn't come out yet. I love a good poop joke. All right, so identifying a direct variation. Does the equation represent a direct variation? If so, find the constant of variation. Well, in order to determine whether or not it is a direct variation, we need to get it in this form of y equals kx. So if you could get it to look like this, then it is. In other words, solve for y. So we did this stuff earlier in the year, but I want to get this y by itself, so I divide both sides by 7. I'm left with y equals, I could either write 2x over 7, or I could do 2/7 x. So this looks like this, where the constant of variation is 2/7. So this first one is yes. Over here, I'm solving for y. So I would subtract 4x from both sides. I get 3y equals negative 4x plus 8. Multiply everything by a third, which is the same thing as dividing everything by a third. That's being distributed there. So I get y equals negative 4/3 x plus, let's see, that is 2 2/3. And because it has this constant here, it is not direct variation. Okay, it has to be exactly like this in order for it to be direct variation, so that one's a no. Here's one for you to try. Go ahead and pause and give that a shot. So the answer will be up in 3, 2, 1. All right, so this is what I got for that one, which means yes, that is direct variation because it looks like y equals kx. Let's keep moving here. To write an equation for a direct variation, first find the constant of variation k using an ordered pair other than 0, 0 that you know is a solution of the equation. So it says, suppose y varies directly with x and y equals 35 and x equals 5. What direct variation equation relates... Hold on. Sorry, I got interrupted by an announcement there. What direct variation equation relates x and y? What is the value of y when x equals 9? So this is going back to that first slide that I had you underline this, where the constant of variation is equal to y over x. Every single time. So here I have a y value, here I have an x value, so I put that y over the x, which is 5, and that simplifies to 7. This is my constant of variation. This is what k equals. So I rewrite my formula, I rewrite my direct variation equation. Instead of k, I write 7. All right, so this direct equation, variation equation relates x and y. Here it is, right here. So whatever x is, multiply by 7, and that's y. So what do you get when x is 9? Well, 7 times 9 is 63. So it's literally just substituting this x in here and solving for it. Pretty simple today. Here's one for you to try. Go ahead and pause and give that a go. The answer will be up in 3, 2, 1. All right, so there's what I got for that. Hopefully you got the same thing. If not, go back and try to find where you made your mistake. All right, so graphing a direct variation, it says weight on Mars y. I'm going to go ahead and just label this y so that I remember. So this right here is my y value, varies directly with weight on Earth x. This one is my x value. And the reason I'm doing that is so that when I go back and I'm thinking, okay, what is the constant of variation? I'm remembering that, that is y over x. And so if I could just identify these things, it'll make it easier to set up in a minute. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So this is the weight. What is an equation that relates weight in pounds on Earth, x, and weight on Mars, y? And then what is the graph of that equation? So I need to take this y value, and I put that over my x value, and this is going to give me my constant of variation, which ends up being roughly, and on these kind of problems, we're going to go ahead and just write that out as a decimal. So it's about 38 hundredths. So the equation says, what is an equation is going to be y equals 0.38 hundredths x. There's my equation. The next thing that it asks you to do is to graph this. And there's a few different ways you could graph this. So if you're graphing this, you could do a couple different things. You can make an XY chart, which is probably one of the easier things to do. You'd say 0 and 0. And we're just going to pick bigger numbers, because if I use 1, that's going to stay pretty small. And I'm thinking of weights. So I'm not really concerned with like 1 pound or anything like that. So we'll do 100, maybe up to 150. And then I go in and I substitute these values into this. And so for 50, I get 19. For 100, I get 38. Multiply this one, I get 57. All right, so now I have some values to graph, so I'll make my graph here. My weight is increasing by 50, so I'll put that on the bottom. So there's my weight. There's my 0. And then a fair value to go up by would be, I don't know, looks like after 3 of them it gets to 60, so we'll just go up by 20s here. Again, your graph may not look like this exactly, but in general it should be the same. So 0, 0 goes here. 50, 19 goes right here. 138 would go somewhere in that ballpark. And then 50, 150, and 57 is going to be something like this. And so this relates the weight, and it would graph like that. Now, one thing I want to point out here is that direct variation always goes through the origin. Okay, and we're going to look at that in more detail in just a second, but it's always going to go through this origin. If it doesn't go through the origin, it is not direct variation. Okay, so the graph of direct variation equation, y equals kx. I don't know why that split apart, and I apologize for that, but you're bright enough to figure it out. Y equals kx is a line with the following properties. The line passes through 0, 0. If it does not go through this, it is not direct variation. Okay, it has to do that. The slope of the line is always going to be k. So this right here, this direct variation is slope. And that's going back to that thing where I was saying direct variation is really slope-intercept form with the y-intercept of 0. Okay, this value right here is the k. They're the same thing. They mean the same thing. One thing that I'll add to this is that direct variation is proportional. It creates a proportional relationship between these values. As one value increases, the other increases at a consistent rate. That is what this means right here, is proportional relationship. So how does this play out? This is for the data in the table. Does y vary directly with x? If it does, write an equation. All you need to do on this one is just see if all these equal the same thing. Divide y by x. Remember, I want to know, is the constant of variation present? So 6 divided by 4 is 1.5. 12 divided by 8 is 1.5. 15 divided by 10 is 1.5. So yes, this one does. And the equation is going to be y equals my constant of variation and then x. This one I need to do some division. I get negative 1.6. Here I get 2.4. I could go ahead and do this one. You end up getting 0.4, but there's absolutely no point. As soon as any of these are not the same, then the answer is no. It does not vary directly. Okay, so this one does because that constant of variation is there. This one doesn't because these values are different. So here's one for you to try. The answer will be up in 5, 4, 3, 2, 1. All right, so there it is. This one is a yes because this has a constant of variation. So I'd write it out like that. That's it for today, so take good notes. See you in class.